know about parallel lines? Because this is a review for you guys. So what do you know? Yeah. Yep. Okay, so the slope is the same. Good, we got that. What else do we know? The y-intercept is different. Good. What else do you guys know? They never intersect. Good. What else do you guys know? They're on the same plane. Okay, good. They're planar. That's a good thing. They're planar. What else do you guys know? That's pretty much it, right? Parallel lines, the slope is the same. They have different y-intercepts. They never intersect. They're on the same plane. That's pretty good. That's pretty good. That's pretty good. So let's do this. So what we're going to do is we're going to show that two lines are parallel. How do you do that? When it says the word show here, what's the calculation you have to perform? What's that? Yeah, no. Well, you could graph it, right? But there's something you have to prove mathematically, algebraically. What's the thing you're trying to show? There you go. You have to show. That means you have to show or prove that they have the same slope. All right. That's what we're doing today. And does everybody know this little thing in the cloud is the symbol for parallel? It's kind of like an elongated 11, right? Number 11. All right. So here's the two lines I'm going to give you here. All right. Here's the two lines. I don't know why that keeps coming up. 2x plus 3y minus 6 equals 0. Let's call that line number 1. And line number 2, let's call that 4x plus 6y. All right. Take a look at the screen here. Hopefully you guys have something very similar to what I've got. On the line number 1, I solved for y. I got it into slope-intercept form, and I figured out that the slope was negative 2/3. Did you guys all come up with that thing as well? Yes, good. And then on line number 2, I put in the slope-intercept form, and again, I showed that line has a slope of also negative 2/3. So since they're the same, we can say therefore, and the 3 dots means therefore, we know that line 1 is parallel to line 2. Does that make sense? Slope is negative 2/3. That's a good question, though. Great question. Okay, second box here. Remember, trying really hard to stick to my 4-box rule here. Can I have you guys? I want you guys to try one. All right, so I'm going to give you an equation, and the equation I'm going to give you is this. I'm going to give you 2x plus y minus 6 equals 0, and I'm going to give you a point, and the point I'm going to give you is 2 comma negative 3. I want you to find an equation that is parallel to this one and goes through this one. Does that make sense? So find another line that is parallel to this one here, but yet goes through this point, 2 comma negative 3. Okay. Here we go. Emily, I saw yours. You had yours done like super fast. Can you tell us what you did and walk me through it? Hey, shh. Get over it. Let's talk. Go. Yep. Hmm? Oh, did you write down a new, like y equals negative 2x plus b, a new line? And then you plug in, yeah, so you did like a negative 3 equals negative 2 times 2 plus b. So negative 3 equals negative 4 plus b, so b is 1. Very good. So your new line looks like y equals negative 2x plus 1. We all agree with that? Okay, let's see if that is actually correct. All right. So what was the first line that we gave? What was the first equation? Help me out. What? Wasn't it 2x plus y minus 6 equals 0, right? Is that what we had? Okay, we'll graph that one. And there's my line right there. Have I not shown you guys this program yet? Okay. And what was the one that we came up with? Negative 2x plus 1. And so what will we expect to see when I put this on the graph? What are we expecting to see? Parallel but different y-intercepts. And look at that, it even gives us a different color. Isn't that nice? So those look parallel to you? Yes. Okay, good. Then we must have done it right. Nice job, you guys. Okay, let's move on to what we call perpendicular lines. All right, brain dump. Tell me everything you know about perpendicular lines. What do you got? They form a 90-degree angle. Good. I like that. What else you know? Opposite slopes. You're half right. There you go. Opposite reciprocal slopes. Good. What else do you know? What else? About perpendicular lines. What's the symbol for it? An upside down T. Yeah. Why is that the symbol for perpendicular? Because it makes like a little 90-degree angle right there. You guys, I don't know if that's true or not. It just looks like it to me, right? So 90-degree angle, they are opposite reciprocal slopes. And do you guys know this one? The product. Now, what does product mean again? Multiply. So the product of two lines that are perpendicular, the product of their slopes will be, anybody think? -1. Very good. So as an example, okay, let's say a line has a slope of 5. What is the opposite reciprocal of 5? It is -1/5. Correct. And if I multiply those two together, if I get the product, what do I get? -1. So that guarantees that those two lines are perpendicular. Does that make sense to y'all? Yeah. Okay, so I'm going to give you the same directions as before. Same little idea here. Same box. Okay. Third box. If I give you this x plus 3y minus 6 equals 0, I'm going to give you a point. The point I'm going to give you is 1, -2. Same directions as the second box. I want you to find a new line that is that's perpendicular. We just did that one. Perpendicular to that line and goes through that point. So we want perpendicular to that line and passes through that point right there. Everyone understand the directions? Say. All right, well, we better talk about this one then. All right, here we go. So how about this? We know 3y is equal to -x plus 6. That was your first step, Mr. Beard? Yeah? So that means that y must be -1/3 x plus 2. Is that correct? So the slope of this line is -1/3. Is that true? Okay, what would be the slope perpendicular to that line? +3. Good. So now I use this slope to get my new equation. Y equals mx plus b. Y equals 3x plus b. And I plug in the point that has to go through this x and y, which is 1, -2. So -2 is equal to 3 times 1 plus b. -2 equals 3 plus b, so b is -5. Dude, I think you are right. So our equation should be 3x. So let's go ahead and graph that to check our work. And in order to graph that, can you guys remember these equations for me? Okay, good. What was the first one we did? X plus 3y minus 6 equals 0. That one? Okay, good. And what's the other one we had? Y equals 3x minus 5. So what are we expecting to see here? Whoa, lag time. What are we expecting to see? 90-degree angle. Let's see here. And look at that. They even give us a different color. So nice of them. What do you guys think? Pretty good? Okay, great. Awesome. Let's get to our last idea of the day, and that would be circles. Circles are awesome. Anybody ever fly over America? Fly over states and look down and see like tons of circle crop cornfields? It's pretty rad, huh? Yeah, like they're so perfect. It's amazing how they do that, right? Wait, how do you think they do that? Aliens. Gotta be the aliens, right? Yeah. There's no way they like stick a stake in the ground and tie a tractor with a pole and just go around and mow it all, right? Yeah. Probably a huge compass lawnmower. Good. All right, so name it. What do you guys know about a circle? Tell me everything you know about a circle. You know nothing about a circle. They're round. That's a good place to start. They're round. Yeah, what else? 360 degrees. What else do you know about a circle? So it has a radius. It has a radius, has a diameter. Good. All these things that we got talking about. Good. It has a circumference. Man, nice job. Has a circumference. What else? It has an area, right? Okay. Wow, all kinds of things, right? So it's round, it's 360 degrees, there's a radius, there's a diameter. What's the radius defined to be? Half the diameter. Good. Diameter is what again? What's the diameter? The length across but it has to go through a very certain. Oh, thank you. So, yeah, very good. Okay. So the key points I want to take away from this one is the equation of a circle. Anybody remember the equation of a circle? Not a clue. Okay, here we go. Let's talk about the equations. If the center is at 0, 0, where is the center 0, 0? What's that called? The origin. Yes, very good. If the center is at 0, 0, then we have the equation that looks like this. X squared plus y squared equals r squared. That's if your center is at 0, 0. The x and the y stand for all of the coordinate points that are r units away from the center. So the r stands for the radius. Okay, and the radius is squared. So x squared plus y squared equals r squared. Now, what if your center is not at 0, 0? What if your center is somewhere else? Now, since the center doesn't change, we give it a certain location, and we call that location h comma k. And the reason we don't call it x and y is because x and y are constantly changing, right? There are arguably infinite number of points around a circle, okay? So h comma k is the one point that is not going to change. That's why we call it h comma k. So now that has the equation that looks like this: x minus h squared plus y minus k squared equals r squared. All right? So the only difference between these two is that one is centered at the origin and one is centered somewhere else. But no matter where your center is, the center never changes for that particular circle. The center is the one spot that, you can point to that's right there. Is that making sense, kind of? Okay, so that's the important part. I want you to write that down. All right, I want you to have these two down, the center and then the h comma k, and then I want us to sort of play with this a little bit here. So let's go to, there it is right here, same information, right? Okay, circle with a center at 0, 0. Here's the equation. X squared plus y squared equals r squared. I already have it set up, so I'm going to go ahead and graph this for us. And check it out. We see an equation. We have a graph of a circle here. Super slow. Lag time, no good. There we go. Let's bring this in a little bit. And let's go a little closer. There we go, that's better. Okay. Now, I'm going to make a slider for the r. So check this out. I'm going to say r is equal to 1. And then I'm going to make a slider of this. Okay? And I'm going to use discrete values. So I'm going to move my slider around for my r. What would we expect the circle to do if I increase my r by a factor of 1? Get bigger. So here we go. If I move this to 1 to 2, what happened? Okay. What if I go over to 4? Ah, okay. Okay, the radius is, there we go, it's my circle here, right? So the radius it tells me the sort of, how big the circle is going to be. Okay? No, 0, there's no circle. There we go, 1, okay? And where's the center of this thing? 0, 0. And he says, is it possible to have negative? What happens if I go negative? Why is my circle still the same? Because we square it. Very good. Okay, now, let's talk about this one here. Here's a circle with a center at h comma k. So we'll go ahead and put this one on the screen, like that. Okay. And what I'm going to do is we're going to say is at 1. And we'll make a slider for that one. And then I'll make a slider for the k. K is at 1. Except it needs to be a lowercase k so that it reads it. There we go. Are you okay? Yeah, there we go. Awesome. It's so slow whenever it records. Okay, so watch this. I'm going to go discrete values for both of them, and I'm going to move the h slider left and right. So what happens if I increase my h to a positive value? Which direction does the graph move? The circle, yeah. Okay, good. And then we're going left here, but so the h value does what to the graph? Yeah, it moves it along the x-axis, right? Isn't that nice that the h part that's with the x-axis moves it left and right? What's the k going to do? Move it up or down. So check it out. So as we move this thing up and down, we can put this circle sort of wherever we want. That's the difference between the h and the k. Does that make sense? Okay, let's go on to this part here. So let me ask you a few questions here. Where is the center and what is the radius? Take a look at this first one here. Where is the center of that circle? This one here. Yeah, say it out loud. Go ahead. Where's the center? 0, 0. Very good. And what's the radius? 4. Very good. How do we get the 4 from that? 16 squared. Good. Where's the center for this one? 0, 0. Good. And what's the radius? Good. Very good. What's the center for this one? Center for this one is what? Oh, no. It's at 3, negative 4. Oh, wait. Why is that? Because that's a minus sign in there. And what's the radius? What's radius? 5. Good. So I'll prove this one to you. So we'll graph. Well, that's not the right one. Sorry. We'll use this button. And we'll graph that one. Well, look. Where's the center? Positive 3, negative 4. See where that? Positive 3, negative 4. And the radius is square root of 25, which of course is 5. Okay, get rid of that. Where's the center for this one? The center is at 2, 4. And what's the radius? 2. Very good. You guys with me on this now? So go ahead. We'll draw that. And check it out. The center is at 2, 4. And the radius is 2. Awesome. And then I think I'm good with that. Good. Okay. Let's go back here. Last part is I want to find the center and the radius. Find the center and the radius, and this is just part B. Center and the radius for this one. This is the most challenging question of the day. And it looks like this. X squared plus y squared plus 4x minus 6y plus... What are you guys talking about? Alright, why does this one look different? Yeah, it's not in the right form, right? Where's the center of this thing? I don't know. So what we have to do, we need to complete the square on which variable is squared? X and? Yeah, so X and Y simultaneously. That's what we're going to do. And it's actually really easy. Check it out. Check it out. X squared plus 4x plus magic number. Now notice I'm grouping all of my x values together. Right? I'm grouping the x values together. I'm going to group the y values together. Y squared minus 6y plus the magic number equals, now I'm going to move my constant term to the right hand side. That's going to give me a negative 12 plus the first magic number plus the second magic number. This is awesome. We are completing the square on both variables in one line of algebra. That is actually pretty awesome. I'll let that sink in. Okay, what's the magic number for the x term? 4, very good. And what's the magic number for the y term? 9, very good. So 4 goes over here, and 9 goes over there. All right, now, who can tell me what's the perfect square trinomial of x squared plus 4x plus 4? What does that reduce down to? What is that? Yeah, very good. X plus 2 quantity squared. Plus, what does all of this sink down to? Y minus 3 quantity squared. Good. On the other side, how much is 9 and 4? 13 minus 12 is 1. Ah, now where's the center of this thing? No. What's the center? Negative 2, 3. And what's the radius? 1, because the square root of 1 is 1. See how cool and how fast and easy